Section 25.3, Cloud Development. So when you have unstable air that rises up, the air is going to cool off, and as it cools off, it can hold less water, so it becomes saturated. And the region where the saturation occurs, we call that the lifting condensation level. It's the level in the air where the air becomes saturated. Once the air becomes saturated, condensation then starts to exceed the evaporation, and clouds start to form. So the lifting condensation level is the point where clouds start to form. It's the lowest level of cloud formation. That air will continue to rise until it reaches a point where the temperature around it is equal to the temperature of the air, and then it'll stop rising. That point's known as the equilibrium level. This is the uppermost limit of cloud formation. The equilibrium level is determined by the environmental lapse rate. It's determined by how quickly the air temperature decreases with respect to height. In terms of clouds in general, we classify them according to their altitude and their shape. There are 10 principal forms of cloud types in 4 different major groups. So here you can see the 10 different cloud types, and we're going to talk about each of these in a little bit more detail. But notice that we have high clouds, middle clouds, and low clouds, and those are all related to their height, where they form. And then we have clouds that have vertical development, clouds that form vertically. So high clouds are those that occur above 6,000 meters or 6 kilometers. And these high clouds are just cold, dry air made mostly of ice crystals. We generally denote high clouds by the prefix cirro. So cirrus clouds are the most common. They have thin, wispy shapes, and they generally indicate fair weather, and they generally move from west to east with the prevailing winds. Cirrocumulus clouds are the puffy cotton ball clouds. They're often found in patches, and they seldomly only cover parts of the sky. And cirrostratus clouds are thin and sheet-like, and they can cover the entire sky and may indicate an advancing storm when they're followed by middle clouds. Middle clouds are those that are between 2,000 meters and 6,000 meters, so 2 kilometers and 6 kilometers. And these are generally denoted by the prefix alto. Altostratus clouds are gray and blue-gray, and they cover the sky for hundreds of kilometers. They generally obscure the sunlight, so objects on the ground don't really cast a shadow, and they often appear before a storm. Altocumulus clouds are gray puffy masses, and they form in parallel waves or bands. They're much darker and larger than cirrocumulus clouds. Low clouds are those that are from the surface up to 2,000 meters or 2 kilometers. These are generally called stratus clouds, and they're made up of water droplets, snow, or ice crystals. Stratus clouds are gray, and they can cover the entire sky. They're very common in winter and sometimes can have light precipitation, and you can kind of think of it as high fog. Stratocumulus clouds are light to dark gray, and they usually do not produce precipitation. They can be distinguished from the altocumulus clouds because of their apparent size. Altocumulus clouds are smaller in the air, while stratocumulus clouds are much bigger. If you hold your arm out, an altocumulus cloud is about the size of your thumbnail, while a stratocumulus cloud is about the size of your fist. And then nimbostratus clouds are the very dark and foreboding clouds. These are the clouds that are generally associated with storms, light to moderate rain or snow. And finally, we have clouds that develop vertically. So cumulus clouds are the most familiar ones. They resemble somewhat like floating cotton, and they can generally occur about 1,000 meters above the ground. And then you have cumulonimbus clouds that are dark cumulus clouds accompanied by precipitation. These clouds often become thunderheads. These are the clouds that form into thunderstorms. So in order for those thunderstorms to form, precipitation has to form. When you have an air mass that's cooled and the water starts to condense and form around the condensation nuclei, you form water droplets. These water droplets are pulled down by gravity, but updrafts in the air work against gravity to essentially hold the water in the air. Eventually, those water droplets can get large enough that they can overcome those updrafts, and gravity will pull them down to the ground. In order for larger raindrops to form, there needs to be some type of vertical development. The thicker the clouds, the more room for the development, thus the bigger and the heavier the rain can be. However, in some cases, the water droplets can be so small that they can evaporate as soon as they leave the clouds. Every raindrop starts to evaporate as soon as it starts falling through air that is warmer where it can be saturated, but if the drops are very, very small, they can evaporate before they reach the ground. And precipitation that entirely evaporates before it reaches the ground, what's called virga. And so finally here you can see all the different types of clouds that form. High clouds, we have the cirrocumulus clouds, cirrostratus, and the cirrus clouds. The middle clouds, the altocumulus and altostratus. And then the low clouds, nimbostratus, stratus, stratocumulus. And then over here you have the vertical development clouds, where you have the cumulonimbus clouds that form into thunderstorms, and then just the cumulus clouds that are puffy and like cotton balls, but much, much lower to the ground than cirrocumulus.